All right, let's see. This is grade 7. This is normally about what goes on in here. Grade 7B. And A. Sorry, A. And I am going to video this unit, chapter 6, which is actually chapter 5 and 6, on the, what is it? All right. Take one, take two. All right, no, we're still rolling. All right, you can sort of see me. Yeah. All right, so we're going to try this. Here's the point. We've been doing this all year. I give you an executive summary on what you need to learn this chapter, from this chapter. So, students, take notes. Yeah, if I tell you it's going to be on the test, right? Make a note. All right? You paying attention? See, I can always pick up the camera and point who I'm talking to. All right, chapter 6, particle theory. Guess what? What can you read from this page, from there? Can you see any words? What does it say?
Solid particles.
Particle theory, right? Do you know what the particle theory is? You can't interrupt me. I just started talking. No. You'll miss this very important lecture. All right, particle theory, what is it? Anybody know?
Theory of particles.
Theory about particles. Nobody really? Chapter 5 talks about the particle theory in the other book. It's basically the same thing. Nobody knows what the particle theory is. This, yeah? Do you think I'm going to ask you a question about particle theory on the test?
Yes.
You can see it from there. So you better know what it is. Here is the basic of the particle theory. Okay? It's really simple. Get this. If you don't already, you probably already got this in 4th grade. But if you didn't, get this, okay? The universe and everything that we know of, this is the theory of the particle theory, is made up of particles, like these marbles, okay? So these would be what we call a model of what I'm trying to describe, okay? So the universe is either made up of individual atoms, right? Like gold is an example, copper, silver, oxygen, carbon, hydrogen, plutonium, whatever, Rutherfordium. It's made up of a series of particles. Those particles can either be atoms or, as in the case of water, right? You have one hydrogen atom and 2 oxygen atoms, and they're bonded together. This is what we call a molecule. 3 atoms bonded together. They're like glued together. They're married. Now, they can separate through a chemical reaction. They can separate and turn back into individual atoms, but everything is made up of particles. We call these particles either atoms or atoms bonded together, which are molecules. Okay? Water is a whole bunch of particles that are H2O. Get it? Now, imagine that these marbles are all particles. Okay? All particles. Doesn't matter if they're molecules or atoms. Okay? They're these little tiny units of matter, right? What's the definition of matter? Anybody? Write this down. You know why? Gonna be on the test. Matter. What is it?
Particles.
Yeah. There's a simple definition of matter. All matter has 2 things.
Weight.
Which we would call mass. Yeah. Because if it's in outer space, it doesn't have weight. Okay? Mass and volume. It has mass. It's made of stuff. It has stuff to it, matter. And it has a volume. It takes up space. In contrast, energy doesn't take up space, per se. All right? So it's a different kind of thing, energy. So, and the universe all together is basically, you can say, is made up of matter and energy. Now, here's the deal with the particle theory, okay? Or the particle model of matter. The same thing. Particle theory, Particle model of matter, same thing. You have all of these particles. These particles right now, these marbles, are the same. This model, if this is a model of matter, this would be the same as liquid, like water, chaya, liquid. Why? The molecules are touching each other, but they're not bonded together. I can put my hand in it, just like I can with water. I could actually, they take the shape of this container, right? Like water. I could actually pour them like water, right? Now what else? I basically cannot compress this. These marbles cannot be compressed because they're already touching each other, okay? That is what a liquid state of matter is, all right? They're not bonded, but they're touching. Now, if I was to spray this with glue or somehow magically make them stick to each other, that would be what state of matter? So they couldn't move. That would be a solid. What happens in a solid is, it's as if I sprayed all these marbles with some sort of glue, and they all glued to each other. Then just like ice, I could pull this whole thing out and it would be the same shape, right? Now, finally, we have the state of gas, yeah? Where water becomes a water vapor. Now, why do these states change? Why does it change? And this is the whole deal about the particle model of matter. What's happening with matter is that it relates to energy, okay? And the more energy it receives, in this case, heat energy, all right? The particles are always vibrating, and they vibrate more and more and more and more the hotter and hotter they get, okay? When they get so much heat energy, they start vibrating away, and they actually split away from each other, and that's what it is when something boils and becomes a gas, okay? That's what it is when there's a gas. All right. Now, there's an interesting thing, and I'm going to need a couple of volunteers in a minute. All right. But there's an interesting thing about this, yeah? Some things, guess what? We don't know how they work in science, right? We don't know everything. One of the most important things you can know is what you don't know. Here's a mystery. Do you guys know what atoms are? The next chapter we'll be talking about atoms, okay? Atoms are, all the particles are atoms. Atoms have a nucleus, all right? Atoms have a nucleus. This is chapter 7, okay? But you can go ahead and write this down. The nucleus of an atom is made up of protons and neutrons. And then it will have electrons orbiting the nucleus. This marble in this case will stand as an example of the nucleus. Around it will have electrons orbiting, okay? They'll be orbiting. Now, it's not like a solar system. They're not just flat, like orbiting around in a flat disk, basically like the solar system. But they're orbiting all around in like a ball shape, okay? And they can have many, many, many. Now, what's interesting about these electrons, and this is one of the things that science doesn't fully understand, these electrons are going super duper fast. They can go around the Earth multiple times in 1 second. Yeah, all the way from here to New York and back. Yeah, really quick. And they never slow down. Basically, they never slow down. What's making them go? We don't know. We don't know. Why do they not slow down? If you take the most powerful rifle in the world and shoot a bullet, the bullet slows down, doesn't it? Because of friction, right? It slows down, but electrons don't, right? So there's something why, yeah? Well, I would say, yeah, people who believe in God would say, well, God makes them go. Yeah, it gives them the energy they need. But they're also affected by a different type of energy, which is heat energy. Now, let's see. Give me some boy volunteers. It could be girl, but boys. All right, you 3 boys, come on up here. Oh, you in trouble, buddy. You in trouble. You want to make another comment like that? You have been just goggled from volunteering. Sit down, be quiet. You, come up here. Yes, please. Can I? Up. Now we are going to pretend to be, don't mess with the camera yet, come over here. We are going to pretend to be, what are we called? Particles. Yeah, we're particles. 3 particles, yeah? We could be either atoms or we could be molecules, all right? Here, come over here. You're not in the camera, yeah? Ooh, it's not quite, it should be lower. It's not the best camera angle. Let me try to adjust that a little bit. Oops, but you see there, that ain't great either. Whatever. Here, let's try this, yeah? I get all right, here we go. All right, so we're particles. Now here's the deal with particles and the particle model of matter. Because atoms have electrons that are moving half the speed of light very fast, okay? Very, very fast. They're always vibrating. They're never standing still. So you guys are particles, so don't stand still. You have to go like this. Okay? You have to go like this. All right? Now, if we're a solid, here's what we do. Like, get all your backs together. Be touching, yeah? Now vibrate. Like this. All right? And I'm attached to you. Now we're stuck. We can't move. Now, what happens is we get warm. Keep vibrating. You're a particle. Particles never stop vibrating. Okay? Now, when we get hotter, we melt and we become a liquid. Okay? At which point the bond between us breaks and we can slide around each other like this. Right? We can slide around. But you see, we're still like a drop of water sliding around. Right? But then we keep getting hotter and hotter. We keep getting hotter and hotter, and we start vibrating like this. Now notice what happens. Notice what happens. Like, let's listen for a second. What happens if we start vibrating more like this? We're going to get further away from each other, right? Right?
Yep.
Try it. Are you vibrating? Now start. Now don't hurt each other. Don't hurt each other. Now, like push away like this. We get further away. The material expands. This is how a thermometer works. When it gets hotter, the liquid inside the thermometer rises because it's expanding. Now eventually, pay attention. Eventually, we get so hot that we push each other away, far away. Go ahead and do that, like this. Now you're vibrating like this, and we become a gas. So this is the whole deal of the particle model of matter. We start to cool down and we come closer together. We contract. The material gets smaller. It contracts. Its size reduces. Mangarati? Yeah? So, what are some things you've learned? You must know this. Do particles always vibrate? Huh?
Yeah.
Are you sure?
Yeah.
How many people say particles always vibrate? Raise your hand.
Marble.
Don't know? How do you not know? I just told you're a particle and you have to vibrate all the time. All right? All right, you guys have a seat. Thank you. Thank you. Good job. Give me a hand. Give me a hand. All right. They always vibrate. Always, guys. It's simple. When they vibrate more, they move further apart and they expand. You got it? Why? Because heat energy is given to them. You got it? They get more energy, they act more crazy, they vibrate more, okay? And then they expand. All right? Now there's some neat things about this. There's one exception to this, which is a miracle, in my opinion. Somebody, whoever created this here place, they knew one little thing had to be different. There's one material which does not obey this principle. There's a couple other, but basically there's one material that doesn't do this. Anybody know what it is? Really common material. I already talked about it today. So this gold, if it gets colder and colder and colder, it's going to get smaller and smaller and smaller. If it gets hotter and hotter, it's going to get bigger and bigger and bigger. The ring will actually get bigger. You can measure the ring getting bigger. Then when it melts, the volume will still get bigger. And obviously, did you know you could turn gold into gas? Yeah, you sure can.
What gas is
Yeah,
it?
3 states of matter, right?
So what is gas from the gold make?
Gold gas.
Gas.